Hey Joe, we're back again. We're going to deal with more intermolecular forces this time. We're going to deal with ion-dipole forces.
Okay.
You feel good about that?
I'm feeling pretty strongly.
Yeah. The more we do this, the more it seems like you're going to know a lot about intermolecular forces.
That's what I'm hoping.
Yeah, good. Okay, Joe, so we have ion-dipole forces here, and we're really... Keep in mind that this is the second strongest force, okay? But this is a very unique sort of situation. So by the end of this video, you'll know more than just intermolecular forces. You're going to understand why things dissolve, why when you add salt to water, it will dissolve. Okay? So, which is a very specialized case. So I can only say to my students out there listening to this that this situation is very specific and only happens in very specific ways, but is obviously very common because things dissolve all over the place, right? So, okay. So the idea here is when you have an ion-dipole force, again, in any intermolecular force, what's going on? You have a what?
You have a positive and a negative, and you have a structure.
Right, you have a positive and a negative attracting each other, right? Opposites attract. So what happens when something dissolves here? So you have sodium chloride that are very strongly attracted to each other. That's a permanent positive attracted to a permanent negative, very strong. So now we have a competition going on. This is the dipole part of this. So if we have water, if we take this sodium chloride and we put it in water, okay? What do we know? Positives like negatives. Opposites attract. So this, what's that little funny symbol there?
So that's a partial negative.
Is attracted to the...
permanent positive.
The positive, right. So there is an attraction there, and I'm going to symbolize that with a little dotted line here, okay? They're attracted to each other, right? Yeah. But which one is going to be attracted stronger? The sodium to the chlorine or the sodium to the partial?
The sodium to the chlorine?
Right, because it's stronger.
I see.
Okay, but why does it dissolve? Well, what's going to happen is we are going to now... Remember, when we put something in water, there's a bajillion, manillion water molecules. So now we're going to get another water molecule in here, right? And so this water molecule is attracted. Okay, and now we're going to get another water molecule in here. And the positive and the negative are attracted here. And so this is attracted. So now we have 3 water molecules attracting this. Is this enough negative to overcome the single permanent negative of the chlorine?
I think so.
Well, and you are exactly right. I think so. I don't know. That's basically, that's kind of... We don't know. But what we know is that there's so many water molecules surrounding this thing that you can have... Now, what if we have another one? Is 4 going to be enough? Who knows? Is 5 going to be enough? Eventually, Joe, what's going to happen is this chlorine is going to drift away because the sodium, instead of being attracted to the one permanent chlorine charge, is going to be attracted to the bajillion little partial charges. And that effect, what you see, is something dissolve. Okay? But let's make sure that chlorine, is also happy, because what the chlorine is negative, so what is it looking for?
So it's looking for the sodium chloride.
Well, it's looking...
Or the hydrogen.
Yeah. So whatever sodium can do, it's almost like Annie Oakley. Anything sodium can do, chlorine can do better. Okay. Anything you can do, I can do better. Right? I can do anything better. Okay, well, whatever. Well, if a water molecule comes in here, we can be attracted, the partial positive side can be attracted to the chlorine, because that's there. And we can do the same thing with the chlorine, with the partial charges on the oxygen, on the hydrogen, that we did with the sodium. And so what happens is everything ends up being happy, and the molecule ends up dissolving.
I see.
And so it's all intermolecular forces. It's about overcoming the single strong force of attraction between the positive and the negative with a whole bunch of little small positives or negatives. And so that's how things dissolve. Cool?
That sounds cool. So then how many particles or sodium chloride go into that until the chlorine moves away?
Okay, yeah. So that has to do with, and that's a very good question. So you're saying how many of these do you need around it in order for this to happen, right? And so that is dependent on, and this is going to be crazy, but it's dependent on the attraction between this and this. The stronger these are attracted to each other, the more molecules you need in order to overcome that attraction, right?
Okay.
Right? And so you have to overrun it. And so this attraction between these two things is basically contingent upon electronegativity. So we can look at electronegativity and we can determine whether something is going to dissolve or not.
Okay.
The more ionic in character something is, the greater the electronegativity difference is between the two things, the more likely it is to dissolve. Any other questions?
Oh, that was about it.
That's awesome. Okay, well, you want to come back and do another one of these?
Yes, I do.
Okay.